Hello, everyone. My name is Matt Barami from Wolfram Research. Welcome to the second session of our live coding series with Mitch Stonehocker. Mitch will do live demonstration of key features of Wolfram language that are very useful in building Wolfram Cloud APIs to JavaScript front end and serverless backends. For those of you who are joining us for the first time, let me add that Mitch has been using Wolfram language for about 30 years. His work experience is quantitative and operational financial markets. Most recently, he has used Mathematica, Wolfram Cloud, JavaScript, and AWS to set up christyhouse.org and other websites. During the first session, Mitch focused on JSON and images. For this session, he will focus on more complex JSON, calling external services, using Wolfram Cloud for storage and images. Without further ado, let us welcome our instructor, Mitch.
Thanks, Matt. Appreciate it. So just by way of review, session one got into the pattern of APIs, at least the pattern of building out APIs the way that I go about it. And hopefully people are finding that helpful. We reviewed some very simple cases so that we could see what the functionality was like and test out some of the JSON requirements once JSON was delivered by the API to the JavaScript front end for further processing into a browser user interface. And so today what we're going to do is we're going to carry on with a little bit more sophisticated use cases, building on top of what we already know to be the three sort of parts of building an API that I go through, which is building out the API function, number one, and then arranging for the cloud deploy endpoint that we need to develop to in the JavaScript front end, and then doing some in Mathematica local testing, some local user testing before we actually get to deploying it in a user interface and a JavaScript user interface. So the key considerations or the key goal of what we're going to get into today is actually looking at some more complex JSON structures and in fact going outside of the Wolfram world to go get those more complex JSON structures, and then working with those JSON structures inside Mathematica to be able to produce the kind of end result JSON structure that we actually want to deliver back to the front end. So there's a very convenient mock data kind of location that I go to for typical kinds of JSON structures, which is called JSON placeholder. If you go to the typecode.com webpage, then what you'll see is when you scroll down the webpage a little bit is that this resource has a number of posts, comments, albums, photos, to-dos, and users with these quantities behind it so that you can easily access any of these resources and you'll receive back some good JSON. So what I'm going to do then is I'm just going to call this API number 5 because that's where we've gotten to. You might remember that we have done some basic user input, get a couple of sample outputs, including some. We got to the point where we were returning using some simple JSON, getting an index, a value, and a name. I won't get into any more detail about using any of this stuff. But some of these kinds of examples are ready to go. Both the JSON code and the Mathematica code for all of these presentations are on my GitHub site. Which is GitHub Mitch Stonehocker, all one word. I can provide links to that as we go along. All right. So the first thing that we want to do is we're going to import in a very straightforward way this URL. And in this case, we're going to hit the endpoint users, and we're going to have that import to us in JSON using the JSON form. And what I'm going to do here is I'm just going to get 3 of these items to show what this looks like. And I'll just open the screen up a little bit more, and hopefully this is presenting in a larger font. I noticed the last session that things were pretty small, but at any rate, you'll see that what gets returned in this case is a list of lists. All right, so this is actually not necessarily as convenient as it could be, because what we can do is we can return from this raw JSON, and which if we do, we'll see that we now have a list of associations, which is really convenient for us, because all we have to do then is wrap our data set around this, and voila, we have a data set structure. So this is very convenient for us, because we now, following on with the prior live coding sessions that we've seen, spent a lot of time both on web scraping, but also on data sets and manipulating data sets in Mathematica. All of the power of our data set manipulation is now available to us just after this very simple little upload. So this is what we're going to leverage. And so one of the things that I always like to do is to create some functional capability around getting any of these kinds of external sources, because it's going to be very handy when we build out our functionality, our API functions. And the way I'm going to do this is I'm just going to create a little function called get, and the parameter is going to be it. And all we're going to do is copy, oops, not that one, this one with the raw JSON. We're going to copy that little thing there, and of course what we have to do is we have to say, well, actually what I want to do is I want to get it. All right, so at this point, as always, I want to be able to clear all as I come up here again, and so now this should work just fine. Let's do a little test here where we want users, and voila, there we go. That's pretty cool. And all we have to do is wrap data set around that, and we're good to go. So what we're going to be able to do then is just as simple as that in our API function, is just use this little function to go get it. And so let's go ahead and start figuring out what of all of this data, right? This starts to become a little bit cumbersome to return all of this in an API. So presumably there's something specific we want to get out of this API. Presumably there's something specific we want to get out of this data set and do something with it, and then return that to the user interface front end. So the first thing I'm going to do then is I'm going to just really wrap this in data sets so that we've got something that we're working with. And now what I want to be able to do is I want to be able to just say, give me a random sample, and I'm a random sample of some number, and I'm going to say 3 just for our testing purposes at this point. And so there you go. We have a random sample, but what you can see also here is that the IDs here are not in any sort of order. So I'm just going to go ahead and I'm going to say sort by, and we'll use the ID field to sort by. And now you can see this is all nicely sorted. And if we do that a couple times just to, yeah, sure, everything's fine there. Okay, so we've got a little bit of logic that says, give me a random sample of 3 users, sort by ID, and what I want to do now is I want to actually pull out some data from this, some specific data from this. And so what might that be? Well, there's actually data in two places. I absolutely want the ID, because I'm going to have to use the ID as the unique element over on the JavaScript side, right? The ID is going to be the unique thing about the row of all of this data, and I can use that ID over on the JavaScript side. So I definitely want to pass ID in, but I also want to get the name. So let's just run that, make sure that's exactly what we get. Okay, that's what we're getting, although this is obviously not returning to us in the way that we ultimately going to want, but nevertheless, we'll deal with that in a little bit. The other thing that I want then is I want something, I want to get this latitude and longitude that is in the geo key area, which is in the address area. So, and I want to be able to get it in the same sort of, passing as I'm getting the ID and name. So what we can do then is outside of name, ID and name, what I can do is I can add in here a query in which what I'm passing to query is going to be the address. So I'm going down the address branch of this JSON object, and then I want to get into the geo branch, right? And so let's take a look at that. And yeah, okay, good. So we have the ID, the name, the lat and longitude of these three items. Check. Yep, that's Irvin Howell, and he's at -43,934. Yeah, okay, so good. I've got the right data. Things are coming along fine. Now, I want to pull this into the good form that I'm after, and rather than spend much time talking about why this data set is returning it this way, and et cetera, I'm just going to go through the process of making it happen. Because, like I say, the other live coding sessions have done a really good job of getting at exactly how to do the manipulations on data sets in order to get exactly what you want out of a data set and produce exactly what you want as a result. So that looks all pretty good to me. I'm highly confident that that's going to produce the kind of JSON object that I want to see. And in fact, you can see that this has a key of ID, an ID number, a key of name, and the name, latitude, longitude, etc. So this is all looking just fine. Pretty confident that we're going to be okay. Now, what I've also done as a little bit of a helper and time saver is I've built out, and at some point I should use Mathematica's palette capability. So with a single click of a palette button, this amount of this code will come out like this. But at any rate, the point is that I know that this piece of code right here, or I'm expecting that this piece of code is going to work for me, right? So, and I do need to normalize that data set inside this function. Trick here. I know that this is not going to work, actually. And the reason why I'm going to put this in here is so that I can get the error to be able to talk about why this is not going to work, and how to deal with it. So the it parameter is going to be a string. Spell right, and the reason for that is because all of the parameters are coming in on all of the parameters are coming in off of an API, which is itself a string, and so this is telling Mathematica how to interpret the things that are coming in, and I need just n. I need a number of things, right? Some number of random sample things. Now, inside this function block, we're expecting to pass two parameters. One is it and one is n. The n is going to go here. So let's do that. Put the n there. Now, it is going to be users. And now, and I'm just going to hard code users here. I'm just going to plug it for now, stub it. if you will. I'm just going to stub it for now so that I don't have to pass in the JavaScript side, I don't have to set up a form control for specifying the user side of the database. Now, when we come down to testing this, then what we want to do is we want to, it can go to users and can go to, call it 3. We'll do something 4. All right, so let's try this. This should all work. And well, actually, not so. And what we're getting is we're getting a missing, not available. And the question is, well, why are we getting that? And again, the reason why I went with this bad snippet is precisely to make this point. What we have here is we have a function inside of a function. So you can see that this random sample is itself a function operating on, operating on this data set, okay? But inside this functional little piece of code here is we're passing a function that is associated with this outer function. So in other words, we have a collision of functions here. We have a collision of parameters in functions, right? So we've got function number 1 that is being passed 2 parameters, one inside and one outside. And so this is what's causing this problem. So we actually have to go back and rethink how we're going to go get this data and pass this in here. So it turns out that it's not a difficult thing at all. And in fact, I'm just going to copy paste this in here so that we can make the direct comparison. And then I'm going to talk through how these are different. So the first, wait a second, let me get the right one. There we go. Okay. So how are these different? Well, it turns out that in order to get around these parameters, these inner and outer parameters being passed to inner and outer functions, the thing that you have to do then is not use a function on the inner side here, right? And we can do that very easily by just saying, well, get users directly inside the random sample. And in this case, I've hard-coded the 3 there. And then what we're going to do, once we have a return, is we're going to sort by, and then we're going to make all of that a data set, and then we're going to act on the data set in exactly the same way as we acted on the data set up here. All right. So it simply is a different way of getting the same data out of that data set, and then acting on it in exactly the same way as we acted on it above. Now, this is going to be just fine. So at that point, then we can, there we go. Copy that over, and let's not forget to add our outer argument to the function. Oops, let me get that correct. There we go. And now, there we go. We've got a result. So we can have 2, we can have, whatever number, and just keep in mind that it has been hard-coded for purposes of keeping the user interface really simple for us. Now, at this point, then, what we can do with the next code block is just say, well, what do we want our endpoint to be? Excuse me. What do we want our endpoint to be? And I'm just going to call the endpoint placeholder. And placeholder is going to be automatically, right, parameterized right in there. And there's absolutely no code difference for when we want to go test this into do a web execute on a Chrome session. And let me just move this over here. And voila, we have exactly what we're looking for. We have an array which has multiple JSON objects in it, which looks just fine for processing over in over in our code. So if we go over in our JSON, excuse me, our JavaScript. So if we go over to the JavaScript side, then let's talk about exactly what we're doing. So on the JavaScript side, I set up a state variable for this component, state for this component, not state for the entire site, but state for this component. This component is app5, and I've hard coded users to set it to users, so that when we come down, you can see that it is used here, and JavaScript already knows that it is equal to users. I don't have to do anything in a form control or anything else to set it to whatever. It is already set to users. All right. You'll remember that from the last session that I build up the URL string by having these first of all, the Wolfram Cloud function endpoint that I'm going to be calling is placeholder. So that's where that comes in. And these others are all of the base and endpoint URL components that are made up, that are produced in the URL string. And then n, you'll see here in terms of the first instance, n is set to an empty string. So obviously that won't work for us. There's actually work to do on the front end side. And in the front end side, we build a form control in which we name n as an item. It's an input type. We produce the value of, and on change event, we set the value n to whatever that form control says it's going to be. And then we have a little bit more logic around it, so that when we look at the form control, when we look at the form control, then what we see is we have users, and this is exactly where a form control could go in order to select users, for example, from a drop down, as opposed to posts or to-dos or whatever else we would want to select from. And here's where we would enter the number of records that we want to get for users. And here's okay, perfect. So we got 3 users, and here's their lat longitudes. Or we want 8, and there we go. There's 8 lat longitudes for 8 different users, and this is exactly how simple it is. So consider, for instance, now that that Mathematica did not invent this data, right? The JavaScript side. The JavaScript side used the form controls to build a URL, which is the API, and Axios managed the await part of this async function, right? Which is called right here on the submit event. When the form on submit, we request the handle the submit, right? So pretty straightforward, really quite easy. And so when n gets passed in to the user interface, the URL is completely built out on the submit, on the handle submit, and over in the JavaScript side, then what happens? Over in the Mathematica side, what happens then is you can see that we're actually calling an external URL to go get the user JSON, which is then random sampled, sorted by, produced into a data set, and then off of that data set we take name and ID, and then we go down the branch into address and geo, and we apply the join across that to put it all in good form for passing back as a JSON object. And so that's how all of this gets put together. So now what we can do with this is just play around with this a little bit more. So what I'm going to do is API number 6 here, and here what we're going to do is we're going to take a look at some additional, a little bit more interesting part, I hope. So in the posts section of our get function, right? We're going exactly to the same website. We're just saying, hey, I want posts, not users. And in the posts, you get this really simple data set of user IDs, that is to say, post IDs. titles and bodies. Now, of course, these words are in the fictitious word kind of thing that is common out there. What do they call it? Some warm or whatever it is. At any rate, they're words and unique words. And so what's interesting for us then is what we want to do is we want to go into body, right? Because what I'd like to do then is I'd like to do a word count for all posts and return the largest number or the largest count, the words with the largest count. That's what we want to return. All right. So there's 100 different posts. So we've got to go figure out how we're going to deal with that. So one of the things that we definitely want to do is in this data set. Let me just copy from here. In this data set, I want to be able to look inside all of this data set at various bits and pieces, or really what I'm after is what are the heads of everything that's inside of all of this. So what we can do here very easily is just say, well, in the body, I want the union of everything that's in body. Well, what I should say is, for everything in the body, give me the head for everything, right? So what this is really doing is it's going inside body, and it's saying give me the head of everything here, and then take the union of the head of all of these elements. And so what this is telling me is that everything, all of these 100 rows in the data set, is a string. Well, that's really good. If, for example, there were any numbers, then you would see string and real or integer, or string and maybe missing. Maybe there was some missing data in there, then you would see string and missing. All right, so this is very informative with regard to the fact that everything in there is very consistent. It's all a bunch of strings. All right, so perfect. So at this point, then, what I want to do is I want to say posts. Now that I know that everything is a string in there, what I can do is I can just say string join on, for instance, if I string join on body, then what we're going to get back is this large string, right? So everything, all of these rows have been string joined together, right? Of course, that's not really what I want. Actually, that's the starting point of what I want. But what I really want, oops, I just hit a wrong key there. What I really want is I want a word count. Not a word cloud, sorry, word count there. So, okay, so yep, sure enough, there's 100 and or 2,286 words, but that's not quite what I want. I want to sort. What am I doing wrong? I want to string join word. I'm sorry. I want a word counts. That's right. Yeah, got it. The difference between word count and word counts. That's subtle but important. All right. So now you're seeing that for every one of the words, and of course these are nonsense words, but nevertheless, for every one of these words, I'm getting a count on. If we go to the end of it, you can see that the quote unquote word, right? ET has 109 instances. Okay. So at this point, though, it would be more convenient if I could reverse that so I could see what the big items were up top. Okay, that's perfect. And now at this point, you can see that what I have here is I have keys and I have values. And that's not really what I want to be. If we were to put this in normal mode, you can see that those are keys and values, and that's not what I want. So what I do want, though, is I want to be able to extract out both the keys and values. Okay. And now what that means is that I have 281 keys and 281 values. All right. So that's pretty close to what I want, but not quite. So if I do a transpose on this, What a transpose is going to do is it's going to link everything up so that now, yeah, you see, I've got values associated with their word counts, right? These are all values. I have no keys in any of this anymore, right? And so what will be convenient for me is to do a take on this so it's not quite so long. Let me just take 10 of these. How's that? Okay, so there's 10 sets of values. Okay, so that's pretty convenient, although it's not exactly what I want, because in JSON, actually, right, both of these values need to have associated keys, right? So the way that I can put all of that together is I can do a function apply like this, where this, right, is essentially a list of values, right? And what I really want to do is I want to take value number 1 and associate it with a key called word, and I want value number 2 and I want to associate that with a key called count. And if we do that, failed. Why did probably because that's outside. I'm going to need to do something like this. There we go. So there's where you can start to see where, all of the words now have a key called word, and all of the counts, the number of times these words exist, all have a key called count. And now in this particular case, I'm not going to worry about indexing anything here. And I'm not even going to worry about it on the JavaScript side either, because what we've done here is we have found unique words so that none of these words in any of this list are going to be duplicates of each other, because, well, then obviously that would have been a problem with word counts, right? So every word is going to be unique, and I can use that fact over on the JavaScript side to be my index. In other words, this word is going to be an index and in the mapping function, and it's also going to be used for the display purposes. All right, so once again, we're going to take this little bit of code here and put it into our function block. And what we're going to want to do is I'm just going to copy paste this for the sake of time. I want to make sure that we get to images today. Again, part is going to be hard coded in, just like in the previous example, because I don't want to take the time to build out the user interface for managing it. But I have to be able to pass in, right, the number of items that I want to return here, the number of words and their count that I want to return here. Okay, so at this point then, part is going to be, in this case, hard-coded to body, and n we will set to 5 for testing purposes, whatever. Okay, and now keep in mind that you see this also is a function. This is a function that we're applying here, right? We're applying this function here, and this is what this little bit of code means. But we're not bumping into the instance in which we're overlaying parameters and functions, right? Because this n is outside of this little piece of function block. Okay, so that we expect this to work just fine. And I didn't quite hit all the keys, and sure enough, there we go. Let's do 15 just to, okay, yeah, okay, fine. That's working just good. All right, so now we can take our next little piece of API function building, and we will call this endpoint word count. Okay, and that's just going to produce the base URL that we're anticipating. And then when we do create a browser session and do a web execute, and if we bring this over here quick, then we got a fail. Now, why did we get a fail? Part body. Why did I get a fail? JSON data set. Type system. Oh, okay. I'm missing on the type system. All right. Okay. String. Let's make sure. Interesting. Okay. Let me, for the sake of brevity, I'm going to just come up here. I obviously missed something on how we're typing all of this. So I'm just going to go ahead and yeah, that's okay. And okay. And okay, yeah, look, I missed something on the typing. I mistyped something. But at any rate, and rather than take your time to go debug that, I just copied over the good working code. And sure enough, what we did, we get our array full of JSON objects, which when we come over here, it's fundamentally the same kind of thing. We have a form control, which is supporting the parameterization of the URL string. The URL string is passed by Axios. Everything is handled in the handle submit function, which is kicked off by the submit button. And when we come over here, we say, yeah, okay, well, give me the 8 most used words, right? Okay, so there you go. So there, again, keep in mind that we're going external to Mathematica to pull in a bunch of posts. We're extracting from body all of the words, doing a word count, and then returning it back to us in good JSON form, okay? So there's one more example that I'm going to try and burn through really fast because it gets into a little bit more of dealing with controls on the user interface and how that plays into managing the API call to Wolfram. Now, in the next part of the get, we're going to call to-dos, and what we want to play around with to-dos is whether or not the to-do is complete or not, so that we'll return back the ID, the title, and the state of the to-do, whether it is true or false, complete or not complete. And so one second. Excuse me. And one other thing that I wanted to introduce here was how we can cloud put this data to Wolfram Cloud. And the way that we can do that is, okay, wait a second. How did I do that? That's right. I must have, well, okay, so let me change up this on the fly. All right. So what we're going to do then is we're going to say, I want to cloud put this data. Remember, we're going outside of my system, any server, Wolfram Cloud. We're hitting an external site out there, and we're pulling in the to-dos, and we're going to save that as a cloud object in data to-dos. This happens to be on my personal, Wolfram Cloud site. So please don't go hitting my personal site just because I made this public. But the point is that this is all there. So we went outside of the Wolfram environment of my machine. We went out into the internet and we pulled in some data and we cloud deploy. We cloud put it as a cloud object into the Wolfram Cloud. And the way that we can test that it is there is to clear all, right, and just go get cloud get from data to dos and see what we get. And sure enough, there it is. There's a whole bunch of to-dos there. And if I was on the ball, I should have thought of this before, is I could go to my Wolfram Cloud account. I'm not going to bother to do it now. I could go to my Wolfram Cloud account and then show in my Wolfram Cloud account the fact that there are folders, data, and to-dos, and that there is, in fact, this data object there in my cloud account, and that's where it lives. So now that it is there, we're just going to go ahead and we're going to go get this cloud get. But right now, what I'm going to do is I'm going to import it as a temp thing, because there's some playing around with it that I want to be able to do. So the first thing that I want to do is I want to be able to do, and I'm going to close that off. The first thing that I want to do is I want to, just like I did before the prior trick, which is I want a union of all things, so that and I want the head of it, right? So I want the union of all heads of everything in the data, in that data set, right? And why did that? Oh, I'm sorry. Oh, yes, of course. So I need to make that a data set first for that to work. Okay, there we go. So, okay, so this is good information. So for example, all user ID items are integers, all ID items are integers, all title items are strings, and all completed items are symbols. Now this is very good to know. So first of all, there's no missing data in any of this. That's what it says. There's no strings in complete. Everything is either a real Mathematica Boolean true or false. There's no missing titles. There's everything. So this tells me, okay, I'm good to go, right? And a really simple way that we're getting that information from. Okay, so what I want to do then is I want to, in this case, I want to select where all complete fields are true, and I just want to take 10 of them, all right? So just to make sure, yes, okay, sure enough. That is a real easy select. Now, there are a couple of considerations, though, about why we would use a select here, as opposed to why we would do something like group by complete, right? In this way. Now, it turns out, you're going to be able to see we got exactly this. Well, actually, except for the fact that I did false here. Let me do true here. We're getting back exactly the same data, which is what we expect from these two different ways of going about getting the data. But the consideration here, though, is that when you're dealing with extremely large data sets, when I see extremely large, is in my history, I've dealt with data sets that are in the many, many millions of rows in the data set. Then what happens when you do a select on a data set on a particular field for some particular state of the field is you're really grinding it to a halt. Well, not to a halt, but you're really causing it to spend a lot of resources, because you're in fact asking it to do the select over the entire data set, as opposed to what you're doing here is you're saying, well, give me all completed items where the key value is true. In other words, if, for example, this data set were made of 50% true and 50% false, then I've already eliminated 50% of the work, 50% of the data that I would actually have to work through before I started looking for the sort by ID and take 10. Okay, so you can see that that there are methods for making quite optimal how you go about extracting data out of data sets and that it really pays dividends when you start to get into very large data sets. So just a helpful hint there. All right. So, and at this point, since this works, what I'm going to do then is I'm going to I'm going to actually, because this is with the temp data, and what we actually want to operate on is the, how am I doing on time? Yeah, okay. What we actually want to operate on is this cloud get data to-dos, and then we want to group by, and this is, oops, I put that in the wrong place, sorry. That has to be in the function block. All right, and you can already see that what we want to do here is I want to have a couple of parameters for the API. One is complete true or false, which is the Boolean, and the number of items that we want to return, and that's those parameters are already sort of baked into this that I have already submitted here. So if we come in here and we add some params here, then we should be running in good order. All right, so yeah, why didn't that quite work? Once again, I must have missed something in there. Lead params, yeah, okay. I'm expecting 4, and I'm getting more. Why am I getting more? What am I doing wrong? I'm going to have to come back to that because in the interest of time. But you see how then the rest of this is simply adding an endpoint, and then starting up a session and do a web execute to make sure that it's showing up in the browser. And if everything goes right, then what we get is we get something like this, in which you've got the way that this is different on the user interface now is I have a couple of checkboxes, one for incomplete and one for complete, and that's going to generate the Boolean, which gets passed into Mathematica, and we can just do give me 10 incompletes, and there we go. Oh, I must have really messed myself up. I'm going to have to go debug my API call post session because I was I'm creating these APIs dynamically as we go. So and I can tell that boy, in 2 minutes to go through the graphics is going to start to get into graphics is going to be a little bit limited. But let me just start off by saying that graphics have some substantial differences with managing APIs than as we have done so far. So far, what we've been doing is we've been building out a form, and on the form we have an on submit control in JavaScript side, and we manage everything about building the URL in a handle submit function. That handle submit function is calling our fetch data function, which is parameterizing everything about the URL and kicking off the API call. So all good. Although that's not the way that it works. That's not the way that graphics or images work in JSON. In JSON, images and graphics have. Let me just bring over my little notebook here so that you can maybe read along. Images have this IMG tag, which has SRC resource paths, and alts, which are whatever the backup is for that. Now, in the image world, you could have static on the server, on the web server domain. You can have dynamic on a external server domain, which is very much along the lines of what we're into. But what we're going to do is we're going to go a little bit further than that, and we're going to actually make a dynamic URL to a dynamic image endpoint in what we're doing with images. And so let me try and get through some of this as fast as I can. And in order to do that, what I'm going to do is come over here and show a couple of different and I think interesting things. First of all, the form of this is exactly what we expect. We see the arguments setting up the API function. We see the function block, and then we have this thing down here called format. What you can see, or an argument called format, well, you can see what I'm doing here is I'm passing in format as an argument to what, for all intents and purposes, could be a module, but in this case, it's just a controlled function in Mathematica terms. And so, when you come down to kicking off the API, then you actually have to pass the format argument to API, and then pass along the the strings or the internal arguments, these guys, right, into this function. So what you can see is that format is an outermost parameter to this function. That A and B get passed along as arguments inside this plot function, and A and B are controlling the Y argument for sine and cosine. This example is taken directly out of standard Wolfram help for plot. I think it's for plot, but at any rate. And then we're just continuing on with A and B to parameterize A and B anywhere else in this function block that A and B is providing us more information. The rest of this is simply building up the styling pieces of the plot, so that it's an interesting kind of thing. Now, the interesting thing about the way that I've built this out then is that when we come down to, or the interesting result of having this API format argument like this is we can pass format also as a string into our cloud deploy function, right? And we can use that as part of the endpoint that we're going to call in the API. And then what we can do is we can just say, well, yeah, here's the list of formats that I want, and I want a unique API endpoint for each of those formats. And so this becomes quite easy to do. And you can see that now what I have is I have 4 cloud objects, each of which with the endpoint for the particular kind of graphic that I'm going to return to this thing. Okay, and so when we come in here and kick off a web session, then you can see that sure enough, for the PNG endpoint, I got a PNG formatted graph, and if I wanted that to be SVG, then I should just be able to hit that, and sure enough, there's an SVG available format. So this is one of the little tricks about building up various different endpoints for the kinds of things that we are going to go on about, and that's very easily done by parameterizing the API function and the cloud deploy function outside of the actual inner function workings that goes on inside here. I'm going to break off here for any questions, comments, anything like that. But before I do so, I'm just going to say that in the next session, we're going to carry on with graphics, because one of the most important things about returning graphic objects is, and by the way, that graphics object is available here. So, for example, if we go 10 and 10, then that you see how that's dynamically updating in the user interface as we play around with entering new numbers and etc. So if we do 150, right? So that's just going to go, and you can see how that's pretty efficient response time. given that you're doing some computation generating the graphics and actually returning 4 different graphics of 4 different formats. The point though is that next time what we're going to do is kick off or restart on figuring out some aspect ratio relationships. In other words, on the front end, you end up having certain aspect ratio requirements typically on the user front end, and there's some sizing and spacing that goes on with regard to how you generate the graphics and how you deliver the graphics as a result of these API calls. And from there, then we're going to carry on with combining table information with graphical information in a single call or in multiple calls, and look at some pros and cons there. So we're starting to hopefully you're starting to see that we're starting to work into some more detailed and more complicated kinds of API calls that can be made, and the kinds of, hopefully this is giving you some ideas about some of the APIs that you can start creating, and the fact that from the API call and actually even from the JavaScript call side, it's actually pretty straightforward to do these kinds of calls, and that the real computational work is all done in Mathematica in the way that's very convenient and comfortable for Mathematica type folks, and even those that are not Mathematica folks Mathematica is not that difficult to learn. At any rate, okay, let me stop there.
So thanks a lot, Mitch. So let's see. It seems there is no comment or question. So in that case, I think there is still plenty of things to discuss about, graphics and images. That would be, I believe, the next session's topic. So that would be a very good point to wrap up our today's session. You were watching the second live coding session with Mitch Stonehocker. You can find the recorded videos on Wolfram YouTube channel. You can interact directly with Mitch through Wolfram community, where he can also download his lecture notebooks. Thanks a lot for watching, and have a good one.